Okay, so now we are starting with the new topic, machine learning and AI for risk management. So in this chapter particularly we have to cover these 4 points: machine learning, then application of machine learning and AI, roles and potential benefits of machine learning and AI, and then the limitation of machine learning and AI. Clear? So these 4 parts will cover up the whole topic. Now the machine learning is again divided into two segments: supervised and unsupervised. Now let us enter into supervised and unsupervised category. So what is the meaning of supervised learning? Basically the word over here is learning. See the word which we are using, machine learning. Okay, now what is that learning actually means? The machine learns the things like human. Machine learns the thing like human. Okay, if I'll give you an example, you will understand it. You have heard of a Tesla car. Okay, you have heard of a Tesla car, and you know that Tesla car comes with a auto drive feature. And on the road, if there is a speed breaker, so means what? Car will first of all see this speed breaker with the cameras. Now the camera will analyze that it's a speed breaker. Now I need to reduce my speed. Clear? And then eventually the car will reduce the speed. How this is coming? This is coming that Elon Musk have trained the system of this car. They have trained the system of this car by showing multiple times the speed breaker of different size and styles. And whenever the car will see something similar to that, it will do what? It will reduce the speed. So means it is told to the machine that if you will see anything related to this, you should reduce your speed. This is the meaning of machine learning. You will make a machine learn that if this will happen, this you have to do. Suppose when you will touch a hot cup, okay, when you will touch a hot cup, then your mind will tell you that drop it. Okay, so your mind is sending you the signal. Similarly, the machine learning is actually the system of the car. As soon as the car see these breaker, the system of the car is giving the orders that reduce the speed. Clear? So we call this as machine learning. This is a human. Okay, human know that it's hot, let's not touch it. Okay, if we have touched it, let's drop it. But how to make this thing with the machine? So we need to make them learn with the help of the data. Now these are the data through which we have trained them. Clear? So this is the meaning of machine learning. Now this machine learnings further divided into two areas. Supervised. Okay, supervised means what? It involves testing the input data to determine the output. Write down. It involves testing input data. It involves testing input data and then determine the output, and then determine output. Now there are different methods which come under the supervised learning. Similarly, there are many methods which come under the unsupervised learning. Clear? In supervised learning, basically there are many independent variables like x1, x2, x3. Okay, you need to find out the relationship of x1, x2, x3 with the y1. Okay, so it's about setting up the relationship between the independent variable. These are the independent variable, and this one is the dependent variable. So it's about setting up the relationship between independent and dependent variable. Now what will happen in unsupervised learning? Basically it focuses only on input data. And from the input data they give the structure of the data. They only give the structure of the data. Means unsupervised learning is not focused about the output. Their focus is only that how the data is actually structured. Clear? Because the learning is not provided in such a way. Means in supervised learning you have given this that if you will find this, you have to reduce the speed. Clear? But if there is something uncertain which you haven't expected, so what it will do, the car will capture that data and it will transfer to the head office. Now head office will again train the machine that if something related to this, then you need to do a cut. Means suppose there is a hole on the road and the camera and the system were not well trained for this kind of system, for this kind of hole earlier. So this time camera saw the hole, but it did not do anything. Why it did not did anything? Because it was not trained. So car went into full speed and did some damage. But this report was sent to the head office, and head office added many such images into the system and trained to the car that if you will see such kind of hole, make sure that if you are going this way, then you will turn yourself little bit left or right so that you will not enter into this hole. Clear? So I have tried to give these examples so that you can relate it what is supervised and what is unsupervised learning. Now remember, there are many things which are discussed in this topic which we have already covered up. Okay, so I am not going to enter into explaining that. Like if I'll give you a small example, that you can see that this involves regression. Okay, so I'm not going to take the regression again, but one thing which I can relate you over here, that one of the method which supervised learning uses is the regression machine learning. Clear? It identifies the relationship between the independent variable and a dependent variable. Suppose if you want to take an example of the credit risk scenario where the dependent variable is the loss given default. Clear? So on what factors it is actually related to? It is related to the history of the borrower. Apart from that, credit worthiness of the borrower. Apart from this, borrowing sources, further borrowing or funding sources, assets which the borrower have. Clear? Or loan to value ratio. Clear? So accordingly we can find out the loss given default. Clear? But now if this is a machine, okay, this is the human who know that these are the value which are related to the loss given default. But suppose the system have added some of the factors like age. Apart from that, factors like that whether he is married or not married. Clear? Apart from that, number of children. So if the system will not be able to find out the relationship between the dependent and the independent variable, the system will automatically throw out these variables. So the human no need to intervene. They will just create a system, they will put the data, and the system will automatically identify that what is going to be x1, what is going to be x2, and what is going to be x3. You have given thousands of variables, but out of those thousands of variables, the system able to identify those three variables where your R square is the highest, where your R square and you remember adjusted R square is the highest. Clear? Now I'm not entering what is this R square, adjusted R square. We have the knowledge and it is not testable in these current issues. So whatever is testable in the current issues, I am going to make sure that you will mark that out. Okay. Now the further regression is divided into two parts. One is the lasso and another one is the ridge. Now what is the difference between these two types of regression? In the case of lasso, what will happen? There are some of the variables like you have seen this age, marriage and number of children. So lasso will give them zero weight. Okay, it give them zero weight and the lasso will throw them out. But what will happen with the ridge? If they are least variable, they will give them less weight, but it will not throw them out. Less weight means suppose there there are 100 variables. Okay, out of those 100 variables, there are 5 variables which are least important. So it will give them weight like this, 0.00001. Okay, but it will not going to remove them. Okay, but a lesser weight which is negligible. Clear? So you can even yourself identify those variables with these least weight. You can throw them out personally. Clear? Because why this ridge is using this? Sometimes what happen now, the data might not be related. The data might not be related, but there is a meaningful relationship. There is a meaningful relationship which is not captured by the system and data, which is not captured by system and data. Clear? Suppose if I'll give you an example, that is a marriage. Okay, marriage. Now data found out that the marriage is nowhere related to loss given default. Clear? But an analyst personally believe that if a person is married, then he will be very senseful. Okay, also he'll be having some sort of assets with himself, that's why he only able to get married. Clear? And he'll be having some responsibilities for his family. Clear? Also there are many people who will come together to save them and their family. Clear? So a person, an analyst, might be the marriage, the data if given this weight, but that person feel that no, it must deserve the weight of 2%, though data is not showing that relationship, but it is a meaningful relationship. Suppose there is a growth of a tree and it is showing a great relationship with the loss given default, that if the height of the tree will grow, the loss given default will also grow. Clear? So data will take this and give this a huge weight, but factually if an analyst will see that it is not related to this, so analyst will remove this kind of data. Clear? So always you cannot give everything in the hands of system. Somewhere analyst will come into and play their major role. Also there will be one more factor which we need to understand, that there are variables x1, x2 and x3. Now suppose x1 and x2, they have a very high correlation. So the system will give high weight to x and low weight to x2. Why? Because it is already captured in x1. Clear? So this is also covered in ridge regression. And one more type of regression, that is LARS. In the beginning, the regression will give 0 weight to all the variables, and later after doing the regression analysis, wherever y1 is suppose related to x1, x2 and x3, the system will automatically give high weight to them, and if suppose x4, x5, they are unable to explain the data. Okay, they are not able to explain the data, so LARS will not give them any weight. Clear? Because it have already given 0 weight to them, so it is only going to give the weight only to those variables which are going to explain the dependent variable, that is y. Clear? Now apart from the regression, there is one more method which comes under the supervised learning, that is PCA, principal component analysis. Okay, now if you remember the main nature of the principal component analysis we have already studied, but if I'll give you a small example from the case of bonds. Okay, one method to identify the risk of the bonds is with the help of modified duration, then effective duration, but they all consider parallel, so we enter into the key rate duration, but then there can be many rates which can be key, so it's not beneficial to do key rate duration, we enter into a principal component analysis, identifying those components which are impacting the bond portfolio, clear, or to those specific areas where my bond is impacted. Three factors which we have discussed earlier was, I think it was in part 1, like steepness of the curve, then level of the curve, and curvature, clear. So principal component analysis also comes under the supervised learning. Now apart from the PCA, there is one more method, that is partial least square regression. Write down partial least square regression. Now what's the main agenda of these two methods? Their main agenda is to reduce the number of variables. Okay, say x1, x2, x3, x4, x5 and x6. Suppose there are 6 variables which are explaining Mr. Y, clear. But PCA or partial least square regression, what they will do, they will combine, say you can combine x1 and x3 based on some information and some data, say x2 and x4 and x5 and x6. So this will become my factor 1, this will become my factor 2, and this will become my factor 3. So now I need to analyze only these 3 factors rather than these 6 variables, clear. So it will simplify, clear. So PCA is more frequently used and easier to comprehend. You can write down an important advantage about the PCA, that it is most frequently used and easier to comprehend, clear. Now when it comes to the steps, it is divided into 2 major steps. One is reduction in scope. Write down reduction in scope. Write down second, application of an advanced machine learning techniques. Application of advanced machine learning techniques. Now why I am saying the advanced? See, with the help of the machine learning, you identify these 6 variables out of say 10,000 variables, clear. But now you are using the advanced techniques to find out the relationship between those factors and joining them together and giving them a weight which will consider both x1 and x3, clear. These all are the methods of highly complicated system, lots of maths and algo done at the end. Okay, so we started with the regression, then we entered into PCA, and now the third one is the classification. So in classification there are many techniques, but we are discussed only with 2, that is decision tree, and the another one is support vector machine, SVM, support vector machine. Now one of the examples which we have covered in our curriculum, which is of a tree nature, is the binomial tree. You remember we have calculated the price of the bond with the help of the binomial tree. But in case of machine learning, there are some of the major limitations with the decision trees, that it suffers from overfitting to existing data. Write down the limitations. Overfitting to existing data. Clear. And it do not have reliable productive power. Write down second, do not have reliable productive power. Clear. Now this productive power reduces when there is a new information and new scenarios. Write down new information and new scenario. If you will remember the binomial tree, if we have a binomial tree, we will use it to find out the price of the bond. But if suppose the binomial tree is not calibrated, if the binomial tree is not calibrated, then we need to calibrate it first. Okay, that was a new information, that was a new scenario. So they are saying that first of all calibrate it, then you are able to use it. Clear? So calibration is one of the method which the binomial tree have to go through. Clear? And when it comes to this second method, SVM, that is a support vector machine, these are considered to be the most complicated, or you can say relatively, okay, relatively complicated, relatively complicated, relatively complicated. And when I am saying relatively, means the decision tree through which I am relating it. Now you can say that they both have the same agenda. They need to classify the things into groups. Clear? Now you have seen a bot chat. Okay, bot chat, many times many of us we have seen that if you message hi on a company's website, it will respond to us that if you want to know about the product, type 1. If you want to talk to the human resource, press 2 or type 2. Getting my point? And when you will type 1, there are many different products. If you want to know further, then press 1. Getting my point? So there are many different classification based on the groups. Okay, and then they create a further subgroups. Over here you can see that there are 3 groups. Then further product is further divided into subgroups. Then that particular product is divided into particular subgroups. Clear? So this is the end of the supervised learning. Clear? Now we will enter into the unsupervised learning. Now whenever I say unsupervised learning, write down unsupervised. Now these are the one which are most difficult in nature. Number 1 is the clustering of the data. Then deep learning, and we have neural networks. Write down neural networks. Definitely we don't have to do any of these, just the meaning that what is clustering, what is deep learning, neural network in just few lines. If we have that information, we are good enough with the topic. Now what is the meaning of clustering? This is basically an unsupervised learning. So you can see that every time the output is not going to correct. So what the main aim of the clustering is? To ensure that from the input they can create a structure of the data. So clustering means, if you have seen your emails, how your Gmail, how your Outlook will be able to segregate those mails which are spam. What will happen? They create a group. Okay, if suppose the mail is coming from such and such domain, they will always put into that spam. So means what they are doing, they are creating a group, and all the mails related to that group will enter into your spam folders. Clear? Or if anything coming with the same number, same name, if the mail is able to read those, okay, they will make sure that your mail will be transferred into the spam box rather than your inbox. Clear? Sometimes even a right mail will enter into the spam box. Why? Because it is not fully correct. Okay, sometimes it can also make mistakes. Because how it will happen, suppose you have received a mail from say GoDaddy and you are not the user of GoDaddy, so you'll put it as spam. They are doing some advertisement and you put it as spam. Now me again, GoDaddy send a message to me, you are Mr. A and I am Mr. B. So GoDaddy send a mail to me. But now this time Gmail learns from this unsupervised learning that if a mail is coming from those domain and it will contain those type of text which are trying to market the things, they will send the same mail to my spam box. Similarly, if C is going to receive the same mail from same domain, same kind of text, same kind of numbers written in the mail, you will find that the Gmail will automatically put it into a spam. But there is another mail coming from the GoDaddy, but in that mail they have written some other text, some different combination of numbers used. It will come to your inbox. But if again you will put that into spam, Now system will learn that this type of mail should be transferred to the spam box for other users as well. Clear? So this is how clustering actually works. Now there are these two areas like deep learning and neural networks. Neural networks, you can take this example that how our neurons works. Okay, neurons, which is the nervous cell, okay, how they works. Similarly, these neural networks actually working in the computer systems. Now there is a machine learning, but this deep learning is the part of artificial intelligence. Artificial intelligence, okay, just like we have the robots, okay, they are the creature of artificial intelligence, which comes under the deep learning. So we are done with the part 1 of machine learning. Now the part 2 is about the application of machine learning, basically to identify these kind of risk. So definitely I'm not going to explain you what is credit risk, market risk or operational risk, but the points which are related to these topics which we have not covered before, I am going to cover all that how machine learning and AI making that credit risk, market risk and operational risk more easy to quantify and to reduce this kind of risk. First of all, if you will see two things, machine learning and artificial intelligence. Clear? So artificial intelligence is the big part of the picture, but machine learning is a very small, you can say, subset of artificial intelligence. In machine learning you are just training the systems, okay, but in case of artificial intelligence you are creating a codes. Apart from that, you are creating the logic rules that what to do, what not to do in all those situations. Clear? So let us see, start with the credit risk. If you remember, I have already given you one example when I was doing the machine learning regression, that how to identify the loss given default with the help of regression. So if you remember the concept of credit risk, there are two main aspects of the credit risk. One is the probability of default and another one is the loss given default, and we need to identify that for every borrower what is the probability of default and what is the amount of risk when we will give them the money. Clear? So over here we are going to use artificial and machine learning to identify and to manage the credit risk, and truly saying that over the past 25 years, 30 years, this credit risk management have really improved when we have incorporated the concept of machine learning and AI. Clear? Now write down three important points. Point number one, since it was proposed that a combined statistical approach, and a neural network algorithm approach, yield far superior accuracy. Means they are giving so much of accuracy when you are calculating the probability of default and loss given default. The combination of what? Combination of statistical approach and neural network algorithms. Neural network algos. Second, we know that CDS, one of the most complicated derivative product which is used for the purpose of credit risk. It is very challenging when you want to identify the likelihood of default, that is PD and LGD. Clear? So write down the next point. It has been demonstrated that non-parametric machine learning models, non-parametric machine learning models, it has been demonstrated that non-parametric machine learning models involve deep learning, which is a concept of AI, you remember, involves deep learning, are superior to the traditional models which we are using earlier. superior to traditional models with respect to accuracy as well as hedging with respect to accuracy. So over here the point comes with the accuracy and the hedging. So when you are hedging yourself from the credit risk, these models are superior. Clear? Now write down the third point. The use of decision tree and SVM. The use of decision tree, you remember it comes under the classification in the supervised learning. The use of decision tree and SVM, which one is more complicated? SVM. Clear? The use of decision tree and SVM have shown to reduce lending losses by up to 25%. Means since the industry have started using this decision tree and SVM, the lending losses have reduced. The losses have reduced by 25%, which is a huge win for them. Clear? So these 3 points are covered under the credit risk. Clear? Now give the next heading of market risk. Market risk. So now when I talk about the market risk, what comes under my mind? Interest rate risk, equity, foreign exchange risk, inflation risk, correct? Apart from that, model risk. Model risk, one of the major risk which comes under the market risk. Okay, you are creating a models, clear? But you are using this model for say trading purpose, clear? So with the help of stress testing, okay, stress testing includes machine learning. If you are using a machine learning which is based on the stress testing, then you can know all the hidden risk, okay, or you can say all the hidden trading risk, or there are some valuation models. There are valuation models. This model is basically for the trading purpose. So you identify all the hidden trading risk. If you are using a model for the purpose of valuing an asset, then you can use an unsupervised learning to know what is the relationship between the assets and the other variables. Assets and other variables. Because suppose you are doing a valuation of a company, okay, so you need to ensure that you are calculating the present value of those assets, future value of those assets, present value of all the future cash flows. So there are thousands of calculations. So over here the unsupervised learning will actually play the role and identify the variance. Variance means the difference between the value which you are expecting and the value which is really or the expected real. One is which you are doing and one is which is expected by the market. What is the variance between them, and accordingly you can take the decision on the valuation. Means suppose you are anticipating the value of an asset as $500, clear, but the market is anticipating for that is say 350. So there is a variance of $150. So that unsupervised learning will help you to identify that what is the variance of the asset, the value of the asset between the normal and your calculation. Clear? With the help of this machine learning and all, the companies were able to increase their profits, the trading profit by 60%. There are some firms which actually trade into the illiquid assets, so they create a cluster of illiquid assets and then they trade. So this will reduces their market impact cost when they are buying and selling. Clear? Suppose they want to sell the asset, and in this cluster all are illiquid assets. So which illiquid asset should I dispose now to satisfy my cash need, where my market impact cost is the minimum? Clear? Apart from that, when you are holding a portfolio, it will tell you rather than holding a one asset, you should hold smaller assets which have the higher correlation with this big asset. Clear? So rather than holding one asset, you should hold multiple assets, because your portfolio will be diversified, and the more you will be diversified, your unsystematic risk will get reduced. Apart from that, if you will take the example of foreign exchange, okay, they use neural networks, decision tree and SVM, so that they can timely warnings about what trades they need to do based on the fundamental changes in the trading pattern. So if there is an immediate action requires, then we are using these methods. Now similarly we have for the operational risk. Okay, operational risk, we have some internal events, also we have some external events. From internal, we know that there are some fraud from the employees, okay, misuse of the fund. External, we know that there is weather related damage, hacking of the computer systems, fraud even from the outside as well. So we use machine learning and artificial intelligence to ensure that we can protect ourselves. So now where we are going to actually utilize artificial intelligence and machine learning, first of all to identify the potential risk, then to measure, then to estimate, and then assess how much is the loss, and then to mitigate the risk. So now if I'll talk about a bank, there is a lots of data, there is lots of documentation, there are many things which we need to do according to a process. Apart from that, there is many money laundering cases. So all those things will also be identified with the help of the systems, artificial intelligence and machine learning. And we are having the automated process, so that all those routine things, like if you need a bank statement, then no employees need to interfere in between. You can go to your net banking, you can download it, okay, so that they can reduce the human error, you can save the time, also to reduce the amount of fraud. Wherever you want, you can take the relevant information regarding you, okay. Apart from that, if you have any issues, any queries, you can raise all those queries and complain online rather than going into the written or verbal communication with the employees. Clear? So this all will actually done via proper system is there with the help of the neural networks and the decision tree, in order to solve the issues which you are facing. Or if you want anything from the bank, like bank statement, amount details, or you want to detect any monetary fraud in the back end. You also know that there is one process going on in the bank, that is KYC, know your customers. This is a document required, and this document required to stop money laundering cases as well as the fraud with respect to banks. Clear? Now the last part, that is the application of artificial and machine learning, is in the help of the regulatory compliance. Okay, now try to understand that there are minimum liquidity requirements, okay, there are minimum SLR requirements, okay. Apart from that, minimum bonds required, treasury bonds required for the banks. So different branches are there all over the world, okay. So data needs to be combined all over the world, and accordingly they need to have their proper debt equity ratios. Accordingly they need to manage the liquidity crunch in their organization. Accordingly they need to maintain the amount of risk. Suppose there is a branch of HDFC bank is in Germany, and which gives away the loan of 10,000 crores, okay, without knowing the risk of the organization as a whole. Clear? So if they are giving this 10,000 crores loan, they need to ensure that if they will give, what will be the risk of the whole HDFC bank. Clear? So for that we need to have the proper system in place which can help us to properly maintain the regulatory compliance of the organization as a whole. Now coming the last two parts of our discussion for this particular lecture. One is the benefit and another one is the limitation of machine learning and artificial intelligence. Wherever you will find benefits, definitely you are going to find some amount of limitations. So benefits are very direct, okay. Just make sure that you write down, point. Start from the time and money spent on the risk management activity. Write down time and money spent on risk management activity, they actually reduce. So write down, reduces the time and money spent on risk management activity. Reduces time and money if we will use artificial intelligence and machine learning. Second, automation of the functions, automation of process and function, automation of process and function, for which you need to devote proper human resource, proper time. Okay, that can be done automatically. The example which you can remember is the downloading of the bank statement. Okay, earlier you need to visit the branch, you need to get the passbook, you need to get it printed, but now you can get it done automated from your systems. Clear? It can provide you more accurate information. So means what? It will increase your accuracy on a real time basis. Clear? It can also sense for the market risk, operational risk, and credit risk. Also, right, they eliminate the unnecessary risk to the firm, before they occur, immediately removing the firm's excessive exposure from that particular area, and adjusting the firm's risk exposure in line, and adjusting the firm risk exposure in line with the general market risk environment. So they are saying that if they feels that the shares of Infosys seems very risky now, so system will understand that Infosys seems risky, they will withdraw the fund from the Infosys, and then accordingly they will invest in the asset from where the risk requirement for the organization as a whole can be matched up easily. So these all are the points which comes under the benefits. Now, when it comes to the limitation, first of all, let us understand that artificial intelligence and machine learning is based on data. Okay, their whole and soul is dependent upon the data, the quality of the data, the reliability of the data. So if I talk about a bank, they have lots of system going on just to collect the data and store the data, and then from that data they process it to get the information. Clear? So every bank, every organization in different places, they just work to ensure that they can collect the data. Based on that data they can take certain action from the information they are getting, and there are some of the areas, some of the organization which do not allow the free flow of the data, sharing of such data. It is very restricted to even the share the data. So data is considered to be as the most important element for machine learning and artificial intelligence. Clear? So sometimes they have their own data, but if they don't have their own data, then they have to purchase it from outside, which might be reliable, might not be reliable. Another limitation with respect to AI and machine learning is the employees. There are very less number of employees who are well trained with machine learning and artificial intelligence. Clear? Apart from that, machine learning, okay, it can be accurate, it cannot be accurate. So before putting up a machine learning system into action, you need to ensure that you will test them properly. If you without testing your system properly, if you put up that system into work, it is going to be a loss game for you. Clear? So these are the few of the limitations and these are few of the benefits. Clear? So we have covered each and every point in detail. Clear? For this particular topic. So just make sure that you will read it once, you will find it very comfortable and you can go ahead with. So I am just closing this lecture here only. Thank you.